Whenever data travels on the internet, whether you're watching this YouTube video, sending WhatsApp message, or making an online payment, it doesn't just magically appear. Behind the scene, the data goes through a series of steps, like a journey. To explain this journey, we use two models, the OSI model and TCP/IP model. OSI stands for Open Systems Interconnection, and TCP/IP stands for Transmission Control Protocol and Internet Protocol. Think of them as roadmaps. They don't send the data themselves, but they explain how data should move step by step. The OSI model. Let's start with OSI. It has 7 layers. Imagine you are sending a letter to your friend. Layer 1, the physical layer. This is like the actual road. Wires, Wi-Fi signals that carry your letter as tiny signals of zeros and ones. Layer 2, the data link layer. This makes sure your letter gets delivered correctly inside a local neighborhood. Here we use things like Wi-Fi, Ethernet, MAC addresses. Layer 3, the network layer. Now your letter needs to travel to the right city or country. This is where IP address and routers comes in. Protocols like IPv4, IPv6 and ICMP lives here. Layer 4, the transport layer. Imagine the post office. Ensuring the letter not only reaches the city but also the exact apartment number. TCP and UDP works here, making sure the right applications receives it. Layer 5, session layer. This keeps long conversations alive. Imagine you and your friend exchanging multiple letters in one chat. This layer manages the connection. Layer 6, the presentation layer. This is about translating the letter into the language that your friend understands and even sealing it safely. Things like encryption, decryption, and compression lives here. Finally, layer 7, the application layer. This is where you actually read and write the letter. It's the protocol we directly interact with. HTTPS for websites, DNS for names, SMTP for emails, FTP for file transfers, SSH for secure logins. The TCP/IP model. Now, in real life, we don't use all 7 layers separately. That's why the TCP/IP model was created. It's simpler and closer to how the internet actually works. It has 4 layers. First, the link layer. This is like combining physical and data link of OSI. It deals with cables, Wi-Fi, Ethernet, MAC addresses. Second, the internet layer. This is just OSI's network layer. It's where IP addressing and routing lives. Third, the transport layer. Exactly the same as OSI's transport layer. TCP and UDP works here to deliver to the correct applications. And last, the application layer. Here, OSI's top 3 layers, session, presentation, and application, are merged. Here is where things like HTTP, DNS, TLS, and SMTP live, mapping and relating them. Think of it this way. When you connect your Wi-Fi, it's link layer. When your device gets an IP address, that's internet layer. When your YouTube app requests a video over TCP port, that's the transport layer. And when the video actually plays in your app, that's the application layer. Why hackers must know this? Now, why does this matter in cybersecurity? Because every attack and every defense belongs to a specific layer. If an attacker sets up the fake Wi-Fi, that's the link layer. If they spoof the IP address, that's the internet layer. If they flood your SYN packets, that's the transport layer. And if they inject malicious script on a website, that's application layer. So, as a SOC analyst, this layer tells you where to investigate when an alert comes. As a red teamer, they tell you which part of the communication you are targeting. So, here's the big picture. The OSI model is the detailed 7-step guide. The TCP/IP model is the practical 4-step version that internet actually follows. If you want to understand network like a hacker or defend them like an analyst, you need both, because when you know the layers, you don't just see the data, You see the entire journey